Sure, at some point in our lives, many of us picked up a pencil and paper and thought, I kind of want to sketch something cool right now. Maybe I could draw something like my bedroom or my pet dog. Unfortunately, a lot of these drawings always end up looking something more along the lines of a Reddit comic than anything. And you just think to yourself, man, I wish I knew how to draw three-dimensional objects. Well, a couple of hundred years ago, a man by the name of Filippo Brunelleschi was thinking about this as well. And he decided to do some experiments, which eventually led to the rediscovery of linear perspective. Later on, this architect by the name of Alberti would document and publish Brunelleschi's findings into a book called De la Peinture, or On Painting, as we call it in English. Turns out this was a pretty big deal in Western Europe, and it was a defining technique used in the Renaissance soon after, as we see here from a painting from Raphael. We still use linear perspective today and are taught it in school. Many art students do find this technique of using perspective to be very abstract and complicated to understand. After all, where are all these points and lines coming from, and what exactly do they mean in the first place? So I think to help understand linear perspective, we should first begin by playing a simple game. The rules of this game are: 1. We are only allowed to draw thin, straight lines, which we will call orthogonal lines. 2. For every line that we draw, it must align with at least one arbitrary point that we place on the canvas. We'll call these vanishing points. I'm using colored lines here to help you with visibility, but if you're doing this on a piece of paper right now, I suggest that you limit yourself to drawing extremely thin lines with a pencil and using extremely thin dots as well. This is because our third rule states that we are only allowed to color or shade in an area on the canvas once we create an enclosed shape using these thin, straight lines. So in the first round of this line game, we begin with 0 vanishing points. I'm sure you probably realized this already, but because there are no vanishing points to draw orthogonal lines from, we can't really draw anything. The canvas is left empty. I wouldn't worry too much though. Let's just see what happens when we add in a single vanishing point then. I can place this first point wherever I want to on the canvas. And what you'll see is that wherever you draw your orthogonal lines, it always has to align with that one vanishing point. And because of this, you eventually see some kind of radial pattern forming. It reminds me of a child's drawing of a smiling sun. Here's where things get interesting now. Remember that third rule that states that we can only color in an area once we've formed an enclosed shape? Well, no matter where we draw our orthogonal lines here, we can never get them to overlap each other, as they keep moving away from the vanishing point. Therefore, we actually cannot color in any spots on this canvas. And remember how I told you that these points and lines are extremely thin? Well, that's because in this game here, all of the lines and points we draw have thicknesses of 0, and they end up covering 0 area on the canvas as well, leaving it completely blank once again. By this same token here, you've also probably realized that to color in sections of the canvas, we're going to need another vanishing point. Adding in a second vanishing point here, which I will color as yellow, we can now draw orthogonal lines that create enclosed shapes, which we can color in. You might notice that this 2D shape over to the left here almost looks like a square. And we could actually make this shape look even more like a perfect square by simply moving the red vanishing point further and further upwards, and by moving the yellow vanishing point further and further to the right. In fact, if we were to have these 2 points move and approach distances that were infinitely far away, then any orthogonal line drawn from them will always appear to be parallel with one another, and we will be able to color in our perfect square without any issues. The direction does not really matter, so long as the 2 points are moving away from each other perpendicularly. A lot of the math people here will probably realize that this grid of parallel orthogonal lines resembles the Cartesian plane used for graphing functions. In fact, we can visualize how some of these functions would look had they have been drawn using linear perspective instead. And obviously, the distortions of this parabola make this method of drawing graphs super unreliable. Now, if you've been drawing around a bit using these 2 vanishing points, you'll find that we still aren't quite at the level of being able to replicate the look of 3D objects just yet. But if we were to add in a third vanishing point, and hence the name 3-point perspective, we can now produce shapes on a flat surface that appear to look 3-dimensional to our eyes. For now, a solid way of thinking about this is that each of the orthogonal lines branching from a vanishing point represent a single dimension. That is why the case with a single vanishing point left us with an empty canvas, as a one-dimensional line by definition cannot take up any area on the canvas. And this is because area in of itself is a 2-dimensional quantity. I'm sure a decent amount of you are probably wondering right now, What about 1 and 2 point perspective techniques that we've learned in school? Clearly those methods can of course draw 3D shapes using less than 3 vanishing points. And if you were actually to look back earlier in the video at the line game, there's a good reason why I labeled each of the rounds by saying just how many vanishing points there were, instead of calling the rounds based off of 1, 2, or 3 point perspective. The techniques of 1 and 2 point perspective, if anything, have a lot more to do with our good old friend, the Cartesian plane. Say we were trying to replicate a 3D object like a box, and we found that some of the orthogonal lines on the box appear to be close to parallel with one another. To be able to replicate this look exactly, we would have had to place the third vanishing point at a distance incredibly far away, which can be rather difficult to draw from without a very long ruler. So essentially, in order to make things easier to draw, artists assume that this vanishing point approaches a distance that is infinitely far away. And this grants them the permission to draw actual straight parallel lines instead. It's a very clever technique, and I use it all the time in my landscapes. And of course, like you can imagine, 1 point perspective is what happens when 2 of these points move in perpendicular directions and approach infinite distances away. You can imagine like you have the Cartesian plane plus another vanishing point somewhere to represent the third dimension. That's pretty much what 1 point perspective is. There are some cases in which you would use either 1, 2, or 3 point perspective techniques when replicating them as drawings. Notice that with the third image here, it was actually taken with an ultra-wide angle camera lens, and thus looks a lot more distorted than usual. It's distorted enough actually that it justifies me using 3 point perspective in this case if I were to draw it out. And you'll find that this wider field of view in distortion is a trend that we'll kind of see more of when we enter 4, 5, and 6 point perspective drawings. Despite this video's length, all of this is really just an introduction towards understanding how linear perspective works. I personally love this topic because learning it in depth requires a combination of artistic, mathematical, and philosophical thinking. To provide you some context as to what I mean by this, eventually we'll be looking at why we should see perspective more in terms of how we can manipulate dimensional planes, which would cause distortions to 3D objects. I hope this video provided you with a basic understanding of how linear perspective works, and how to utilize it when creating artworks in the future. That's all for today. Thank you for watching, and have a good one.